In the realm of science and profound knowledge, the subject of what existed before the massive event of the Big Bang has sparked mixed discussions and captivated thinkers for decades. This monumental question doesn't just challenge how we understand the universe. It also tests the very boundaries of human knowledge. Imagine standing on the edge of existence, peering into the vast unknown, and wondering what lay there before our universe was conceived. The event of the Big Bang marked the beginning of space, time, and everything we know. Yet, was there a moment before this? A state of nothingness, a silence before the great cosmic symphony began? If this is true, was it simply a void, or could there have been something even more mysterious that existed before time itself? As we delve deeper into this profound inquiry, science takes us on a journey beyond the early stages of the universe, into realms of thought that challenge our understanding. Physicist Brian Cox, known for his dedication to exploring the wonders of the universe, suggests that something extraordinary could have existed before the Big Bang. He invites us to rethink our perceptions of reality and existence. In this exploration, we'll unravel the science, theories, and fascinating secrets that may explain what existed before everything we know. We'll examine ideas like eternal inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may leave us astounded, but they could also provide new insights into our place in the cosmos. Prepare to dive into a world beyond imagination and science, a realm where shadows linger and mysteries abound, leaving scientists both amazed and, at times, unsettled. What was the Big Bang? To appreciate what might have existed before the Big Bang, we must first understand what the Big Bang itself was. As science describes it, the Big Bang refers to the moment when the universe became extraordinarily hot and dense, expanding rapidly to form all matter, energy, and fundamental forces. When we look at the night sky, we see evidence of this hot beginning, with galaxies spreading out from an initial point. But why did this happen? Was there a time before this dense, hot start? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or silent. Cosmic inflation suggests that prior to the Big Bang, the universe existed in a state that was cold, empty, and nearly featureless, a vast vacuum. Yet this vacuum wasn't entirely devoid of content. It held a tremendous amount of energy that fueled the rapid expansion of space itself. The inflationary multiverse. This expansion, known as inflation, occurred so quickly that it laid the groundwork for everything that would follow. The energy from this inflation transformed into particles, forces, and the structures we recognize in the universe today. But what was the nature of this energy? Why did it emerge seemingly out of nowhere? And why did it stop? Scientists propose that this rapid expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric expanding endlessly, with tiny bubbles forming within it. Each bubble represents a universe, including ours. This idea, called the inflationary multiverse, suggests that there are potentially countless Big Bangs and an infinite number of universes. Our universe is just one of many. The nature of nothingness. The concept of nothingness before the Big Bang is deeply theoretical. Even if you remove all energy, particles, and radiation from the universe, it wouldn't truly be empty. Our universe is imbued with dark matter, dark energy, quantum fields, and other forces that make true emptiness nearly impossible. Even in its most stripped-down state, the universe would generate new forms of energy. This notion confounds scientists, as it implies that true nothingness might be unattainable. Space itself has properties, rules, and constants that prevent it from being completely void. For instance, quantum fields exist everywhere, even in a vacuum, and they have a lowest energy state called zero-point energy. In this state, particles can still appear and disappear, creating a faint echo of activity even in seemingly empty space. Eternal inflation and the multiverse. One of the most fascinating theories in modern cosmology is the idea of eternal inflation. If inflation created our universe, it's possible that it could continue indefinitely. Brian Cox describes an incredible inflationary multiverse where universes are continuously created and expanded. Imagine each Big Bang as a spark, igniting another universe while inflation occurs in different regions, generating endless new universes. This process could, in theory, go on forever. This idea of infinite universes gives rise to a mind-bending vision of a fractal-like cosmos, where each new universe might generate its own Big Bang. Quantum fields and virtual particles. Our understanding of nothingness evolves when we consider quantum field theory. According to this theory, the universe isn't just a collection of matter floating in space. It's a complex web of energy fields that interact to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even in their lowest energy state, known as the vacuum state, these fields remain active. Particles can appear and vanish momentarily, borrowing energy before returning it. This phenomenon leads to the existence of virtual particles, entities that exist for an instant before disappearing. This challenges the very concept of a true void. Conclusion: the idea of before the Big Bang pushes the limits of science and imagination. From quantum fields and eternal inflation to multiverses and the elusive nature of nothingness, these concepts challenge our understanding of existence itself. Perhaps the most profound realization is that what we perceive as nothing may actually be teeming with potential, a canvas for the creation of universes. The quest to uncover what existed before the Big Bang is as much a journey into the mysteries of the cosmos as it is a reflection on our place within it. Dark energy and the pre-Big Bang universe. Dark energy, a mysterious force that drives the accelerated expansion of our universe, poses intriguing questions about its origins. Could dark energy have existed before the Big Bang? Some theories suggest that it might be a remnant of an energy field from a pre-existing state of the cosmos. Dark energy's properties hint at a profound, enigmatic force, one that could have played a role in the conditions leading to the Big Bang. Its persistent presence challenges our understanding of how energy and matter behave on cosmic scales, particularly in the context of what existed before our universe's expansion. Cyclic universes and eternal rebirth. An alternative to the inflationary multiverse is the idea of a cyclic universe, where the cosmos undergoes infinite cycles of expansion and contraction. In this model, the Big Bang isn't the absolute beginning, but rather a transitional phase between two states of the universe. After a period of expansion, the universe could eventually collapse back into a singular state, triggering another Big Bang. This endless cycle of birth and death creates a framework where the universe has no true beginning or end. Quantum gravity and the nature of time. One of the biggest challenges in understanding what existed before the Big Bang is reconciling quantum mechanics with general relativity. Quantum gravity, a theoretical framework that combines these two pillars of physics, may provide insights into the nature of time and space before the universe's formation. In some models, time as we understand it might not have existed prior to the Big Bang. Instead, the universe could have emerged from a timeless quantum state, a quantum foam filled with fluctuating energy fields. The role of multiverses. The multiverse theory offers another perspective on pre-Big Bang conditions. If our universe is just one of many, then the Big Bang could be a localized event within a vast cosmic structure. Each universe might have its own physical laws, dimensions, and histories, creating an infinite array of possibilities. This view not only expands our understanding of reality, but also raises profound philosophical questions. If multiverses exist, what is their purpose? And how does our universe fit into this infinite tapestry? The limitations of knowledge. Despite the progress made by science, the question of what existed before the Big Bang may ultimately remain unanswered. The nature of the universe's origins challenges the limits of observation and experimentation. While theories like inflation, quantum fields, and multiverses provide compelling possibilities, they are for now speculative. The search for meaning. What existed before the Big Bang isn't just a scientific inquiry. It's a philosophical and existential one. It forces us to confront profound questions about existence, the nature of reality, and our place in the cosmos. Whether the answer lies in the infinite cycles of a multiverse, the mysterious properties of quantum fields, or something beyond human comprehension, the journey of exploration itself is a testament to the boundless curiosity of the human mind. Before the huge explosion, some hypotheses recommend that dark energy, in a much stronger state, could have powered the inflationary stage, causing rapid expansion. The presence of dark energy suggests that even if our universe were devoid of all matter and radiation, this force would continue to shape the fabric of space-time. This idea leads to an intriguing question. If dark energy existed before the Big Bang, could it have eventually created the conditions that led to the birth of our universe? Might dark energy be the silent architect of expansion, or even the true beginning of our universe? As we explore this possibility, we face the idea that dark energy might not merely be a force shaping our universe, but also a key to unlocking the mysteries of the multiverse itself. Another hypothesis, cyclic cosmology, offers an alternative to the Big Bang as a definitive beginning. This theory proposes that the universe undergoes massive cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event, but rather part of an eternal cycle where universes form, evolve, and then collapse into a new cycle. This hypothesis suggests that our universe could have been reborn from the remnants of a previous one. The process of compression and expansion in a cyclic pattern implies there was never a true beginning, but instead, an infinite series of universes arising, creating, and renewing themselves over and over. Cyclic cosmology raises profound questions about time, as it implies that time itself could repeat rather than progress linearly. If this theory is correct, it could mean that what existed before the Big Bang was simply another form of the universe, one that collapsed only to give rise to our current universe. For scientists, this hypothesis offers a rich explanation for the concept of extreme beginnings, suggesting that there is no clear origin. The universe has always existed in some form, transcending our notions of time and existence. Gravitational waves provide another fascinating avenue to explore what existed before the Big Bang. Discovered in 2015, these ripples in space-time are caused by incredibly massive objects like black holes or colliding neutron stars. These waves can travel great distances, carrying information about the events that created them. Could gravitational waves reveal insights into the birth of the universe? Some physicists suggest that waves originating from before the Big Bang might offer clues about the state of the universe before inflation began. Early universe gravitational waves might contain traces that help us understand whether the Big Bang was truly the beginning or whether there were cosmic events we have yet to comprehend. These waves might be remnants of events beyond our usual understanding. Their presence could hint at a grander structure beyond the observable universe. These faint signals could unlock knowledge that changes our perspective, much like how we discovered the Big Bang itself. What if these signals reveal remnants of a past universe or events that occurred before the Big Bang? As scientists continue to probe the depths of space, the question remains, what existed before the Big Bang? With modern theories pointing to quantum mechanics, multiverses, and cosmic inflation, we are closer than ever to uncovering the deep mysteries of the universe's origins. While the ultimate answer remains elusive, our understanding of what existed before the Big Bang evolves with each new discovery. As we explore these theories, we can also consider how they might fit together to reveal the bigger picture, the true nature of existence itself. Until then, we are left with the mystery driving science, pushing us into uncharted territories far beyond what we have known. As we continue exploring the question of what existed before the Big Bang, time itself becomes increasingly difficult to grasp. Time, as we understand it, began with the Big Bang, making the concept of before somewhat paradoxical. If time didn't exist before the Big Bang, can we even discuss something existing prior to it? Some theories suggest that time might not have a clear starting point and that our understanding of it is limited by the current framework of physics. One intriguing aspect of these theories is that they open up the possibility of new laws of physics, laws that have not yet been discovered or even imagined within our current understanding. If the universe, as we know it, began with the Big Bang, and before that there was a state of nothingness or cosmic inflation, what governs the forces and particles in that pre-Big Bang state? Could there be a fundamental layer of reality that transcends time and space, where the standard laws of physics completely break down? This metaphysical layer would challenge everything we know about the universe, yet it might hold the answers to some of the most profound questions. Some experts speculate that the beginning of the universe might not have been a singular event, but could instead be the result of interactions between higher dimensional forces. According to string theory, for example, the fundamental building blocks of matter are not point-like particles, but rather one-dimensional strings vibrating at different frequencies. These strings might exist in higher dimensional spaces beyond the three-dimensional space we can observe. If this theory holds any truth, our universe could be just one slice of a higher dimensional space, intersecting with others to form the multiverse. In this scenario, the Big Bang could represent the intersection of these dimensions, with a continuous cycle of universes being created and destroyed in higher dimensions. Moreover, theories like the brain model suggest that our universe might have resulted from a collision between two higher dimensional brains, membranes of spacetime, existing in multiple dimensions. These collisions, if they occurred, could have triggered a Big Bang-like event, starting a new cycle of expansion and contraction. Such models provide a framework for understanding the origins of the universe that doesn't rely on a conventional singular beginning, but instead introduces a scenario of perpetual rebirth through cosmic events. This idea challenges our traditional thinking about the universe's beginning and opens up possibilities for how it might evolve in the future. Furthermore, these cosmological theories often intersect with philosophical questions about the nature of existence itself. If time, space, and matter have always existed in some form, does this imply a timeless and eternal reality beyond our perception? Or are we part of an infinite cycle of creation, expansion, and destruction? Some have even suggested that the answers to these questions lie outside the domain of science entirely and may only be fully understood through spiritual or philosophical inquiry. This raises the possibility that the limits of human understanding may not just be about technological advancements in physics, but also about the profound existential nature of reality itself. In conclusion, while we may never fully answer the question of what existed before the Big Bang, the theories and ideas surrounding it provide a rich tapestry of possibilities. As our understanding of quantum mechanics, dark energy, and cosmology continues to advance, we may inch closer to uncovering the true nature of existence, time, and the universe itself. As researchers delve deeper into the origins of the universe, they are increasingly confronted with the interplay between theoretical physics and observable phenomena. Tools like advanced telescopes, particle accelerators, and simulations are expanding our capacity to understand the conditions surrounding the Big Bang and what might have preceded it. One promising avenue of exploration lies in quantum mechanics, particularly the idea that the early universe was governed by quantum fluctuations. These fluctuations could have sparked the formation of the universe from an initial quantum state, where the classical notions of space and time were undefined. Theories like loop quantum gravity attempt to describe this pre-Big Bang phase. In this framework, space-time itself is quantized, consisting of discrete chunks rather than a continuous fabric. If true, it could suggest that the universe bounced from a prior contracting phase, avoiding a singular beginning. Another concept gaining traction is the multiverse hypothesis. This theory posits that our universe is just one of countless others, each with its own set of physical laws and constants. The Big Bang, in this view, may represent the birth of just one bubble within a vast multiverse, where universes constantly emerge and evolve. Such ideas also lead to philosophical implications. If the multiverse exists, it raises profound questions about meaning, purpose, and our place within an infinite cosmos. Are we the result of chance? Or is there a deeper, as yet undiscovered principle driving the emergence of these universes? In addition to theoretical models, observational efforts are ongoing to gather evidence of these early cosmic phenomena. The cosmic microwave background, CMB, radiation, for example, provides a snapshot of the universe as it existed roughly 380,000 years after the Big Bang. By studying subtle patterns in the CMB, scientists hope to uncover traces of the physics that governed the universe's first moments, or even clues to what came before. Gravitational wave astronomy is another rapidly developing field. With detectors like LIGO and Virgo, researchers are beginning to explore signals from extreme cosmic events, such as black hole mergers. These technologies might eventually detect primordial gravitational waves, providing a direct glimpse into the universe's earliest epochs and the forces at play before the Big Bang. The search for understanding is not limited to physics. Philosophers and theologians are also deeply engaged in discussions about the ultimate origin of reality. Some argue that the universe's beginning, or lack thereof, points to the need for a cause beyond the physical realm, potentially a metaphysical or divine explanation. Others propose that our conceptions of time and causality may be too limited to address such questions. This convergence of science, philosophy, and metaphysics highlights the complexity of the question, what existed before the Big Bang? It suggests that the answers may require not only scientific breakthroughs, but also new ways of thinking about existence, causality, and the nature of reality itself. As humanity continues to push the boundaries of knowledge, we may uncover answers that revolutionize our understanding of the universe. Or, perhaps, the ultimate truth will remain a mystery, inspiring generations to continue exploring the profound depths of existence. Until then, the question of what preceded the Big Bang serves as both a scientific challenge and a philosophical enigma, one that encourages us to dream, question, and strive for a greater understanding of the cosmos and our place within it.